All right. Good morning, sports campers. Today, we are going to jump back on the Advent of Code bandwagon with day 11. Okay, so let's get my microphone back in position. Still mentally recovering from day 10. It was a bit of a doozy, but I'm excited to be back for day 11. Let's get started. All right. Oh, it's a map one. I kind of like map ones. I don't know why. Though they always trip me up because I always have to remember X and Y. I'm like X, Y, and then whenever invariably I break these maps up into like arrays of arrays, if I do that, I don't know why Siri keeps getting triggered, but occasionally you'll hear Siri pop in and be like, hey, what can I do? Whenever I break these up into arrays of arrays, I invariably also always forget that Y comes before X, because when you break lines up, that's the vertical, and then there's the horizontal. It's comprised of horizontals. Messes with my head every time. So hopefully I won't make those mistakes this time. And if I do, maybe you can warn me about it in the chat. The chat, generally speaking, on the stream, there is a bit of a delay, it looks like, between what I'm doing and the broadcast. It looks like maybe about 10 seconds or so, but I do appreciate helpful hints. Obviously no straight up answers, but if you feel like I'm missing something or getting stuck, I really do appreciate it. If you drop a hint in the channel for me, or in the chat for me, or we could treat it as kind of like a weird pair programming session, where if you notice that I've made a typo, or I've made a mistake, like an obvious mistake, I would love for you to point it out to me. I kind of think this like pair programming, and I kind of record this as if I'm pair programming. So this is very much what a pair programming session would be like, except with an obvious handicap on the communication aspect. So anyway, think about it like that, and drop a note in the chat or whatever if you feel like you'd like to. Happy for the company for no other reason. Okay, so let's copy this into our paste buffer, and then we'll read today's problem, and then we'll talk about it, and then we'll look at solving it. All right. Day 11, seating system. Your plane lands with plenty of time to spare. That's nice. The final leg of your journey is a ferry that goes directly to the tropical island, where you can finally start your vacation. As you reach the waiting area to board the ferry, you realize you're so early, no one else has arrived yet. Oof. By modeling the process people use to choose or abandon their seat in the waiting area, you're pretty sure you can predict the best place to sit. You make a quick map of the seat layout, your puzzle input. Okay, the seat layout fits neatly on a grid. Each position is either floor, an empty seat, or an occupied seat. For example, the initial seat layout might look like this. All right, so it looks like a bunch of empty seats and a bunch of floor spaces. All right, now you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. Okay, all decisions are based on the number of occupied seats adjacent to a given seat. Well, no one wants to sit next to a stranger. One of the 8 positions immediately up, down, left, right, or diagonal from the seat. The following rules are applied to every seat simultaneously. The following rules are applied to every seat simultaneously. Okay. Interesting. If a seat is empty and there are no occupied seats adjacent to it, that seat becomes occupied. This feels a little bit like Game of Life so far, which is kind of fun. If a seat is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Yeah. Otherwise, the seat's state does not change. Yeah, this is extremely close to game of life so far. Okay, so hold on. Let's get a quick recap on adjacency. So number of seats. Where was that talk about up, down, left, and right? Seat layout. Okay. Yes. Now. One of the 8 positions immediately up, down, left, right, or any of the diagonals. Okay. All right. Cool. Floor never changes. Seats don't move, and nobody sits on the floor. Okay, so floors are just always empty. We just never have to consider occupying a floor space. However, we would consider that empty, I think. Okay, so after one round of these rules, every seat in the example layout becomes occupied. Yeah, yes. After a second round, the seats with 4 or more occupied adjacent seats become empty again. Right, okay, so this didn't have 4 or more empty seats, adjacent seats, because it had 1, 2, 3 adjacent seats at all, and only 2 of them were occupied, so it didn't flip. This one had 1, 2, 3, 4, 5, had 5 adjacent seats, 4 of which were occupied, so it flipped, vice versa, or same for that. Okay, that makes sense. After a second round, the seats with 4 or more occupied adjacent seats become empty again. Process continues for 3 more rounds. At this point, something interesting happens. The chaos stabilizes, and further applications of these rules cause no seats to change. Wow, okay. Once people stop moving around, you count 37 occupied seats. Simulate your seating area by applying the seating rules repeatedly until no seats change state. How many seats are occupied? Okay, cool. So this is... for those of you who've never had the great pleasure of doing Game of Life, this is kind of like a spicy version of Game of Life, which I think is kind of cool. Day 11. So that said, let's get right into it. All right, come on. Seating system. All right, so we're going to clean up this markdown. So this is our input. Input. There we go. All right. So there were a couple of like interesting tidbits in there that I recognize only because I've played with Game of Life before, which is that all the seats are evaluated instantaneously, which means that you can't traverse over these and apply the decisions directly. Like, you can't be like, oh, this is empty, so it's going to become whatever, and then this is whatever. You actually have to operate on a copy of the array. So what you end up having to do is, here, I'll see if I can do a multi-line thing. Okay, so what you actually have to do is you have to clone the array, and then you have to evaluate this one and make the change to this one. It's sort of like a frame buffer with video games. It's like you have to write your results to a new frame essentially, and then swap in the frame. And that's where most people get caught up in Game of Life. And I think that's one of the things that make it a great tool for talking about programming or teaching programming, is because you know that there's sort of like one gotcha that you can talk about. How are these split up? There is, oh, that's weird. There is like a blank line between these, but it's not showing up. So every third after. Okay, so this dot followed by, or yeah, this hash dot followed by hash L is where it is. So hash dot followed by hash L. That's the first one. Hash dot followed by hash L. Okay. All right. At this point, so I feel like just making this markup was almost more of a challenge than it should have been. Okay, so we got our input. We got our different boards. All right, cool. That looks good. Neat. So let's get started. First section is where we will define the code. I don't know. I still haven't come up with a better name for this. If you can think of one, please drop it in the chat or in the comments. And then we're going to have our tests. We're going to test that what we make works. And then finally, we're going to have this section right down at the bottom where we just log the output of whatever we come up with. So we've got this input, and we want to assert that after it stabilizes, we have 37 occupied seats. So how can we do this? I guess one way we can do this is we can split this into a grid, and we can actually we can look at the grid spaces around it in terms of X, Y. That is absolutely something we can do. In fact, I think that makes sense because we have these edges. So if we didn't split it into a two-dimensional array, if we pretended it was like this, and just looked forward and backwards the appropriate number of indexes, we'd have to make special accommodations for the fact that this is not a neighbor of this, even though it's right next to it in the array. So I'm thinking that it would make sense, because this effectively only has 3 neighbors, and we need to kind of know that. So I'm thinking we should just split these up into an array of arrays. So that's the first thing we're going to do, is we're going to parse input. So here, let's bring our old friends log and assert in, and assert equals, let's see if I can require it today. That was a fun bug. Okay, so we got log and assert, and what we want to do is we want to log parse input, and we want to wonder, is there I know that sometimes in the browser there's different console logs. Maybe there's a nicer way to do this. I don't know. Anyway, we'll just log it for now and see what it looks like. So we're going to break this, whoops, not that one. We're going to break this input up into an array of arrays. So parse input, it's going to take text. We're going to do text split on new line, and that's going to give us our rows, and then we need to map those rows, and so that's going to give us our row, and for each row we're going to split them into columns, and then what are we going to do? How are we going to mark these? We could leave them as is. We could leave them as symbols, because we've got 3 states, right? We've got it's a seat, it's an empty seat, it's not a seat at all, it's floor, and then if we have a hash, then it's an occupied seat. So it doesn't really lend itself well to just doing true false. We could do true false and undefined, and then we have to be, or true false and null, and we have to be explicit about checking for true and false. At that point, I wonder if, you know what, I like that, and I like that for the reason that if you're looking at the neighbors, you don't have to be very explicit, because a false and a null are both falsy. So when you're evaluating the neighbors, you don't have to worry. You can sort of collapse those states. So let's do that. Let's turn these into true, false, and null. So right now they're all going to be either true or null. So it's going to be row split on nothing, and then map, and that's going to be our individual row value, which is going to be text. This is getting to be quite involved. And then we are going to say, okay, so if it is that, then it's going to be false. So I'm going to say we can make this a switch statement. So when we could do false, and then when dot do null, when, you know, like, I'm going to throw this in here just so we can evaluate future ones. When L, or when, oh, sorry, it's L is false, L, and then when that, say true. Let's throw this up here, true, false, null. So is the seat occupied, is the seat not occupied, or is it not a seat at all? Okay, cool. So that's our parse input. Let's log it, see what we get. Get parse input is not defined because we have to set it equal to something. Okay, cool. So that's interesting. It gave us true for everything. Oh, because we're not switching on anything. Switching on the value. Okay, so here we go. False, null, false. So let's look at our original input. False, null, false, false, null, false, false, null, false, false. Okay, so that's exactly what we wanted. Let's just switch it up to see if the first one becomes true. And whoop, it does. Good. Okay, so parse input is giving us what we want, which is this array of arrays. So it's giving us the first dimension of the array, which is the rows, and then the second dimension, which is the columns. So when we access them, we need to do yx, because I made that mistake before. Okay, cool. So what's next? Let's take a look back here. Okay, so we need to apply some rules to these. I guess there's another utility method we're going to need at some point is we're going to need to count the number of occupied seats. So since we've turned this into true, false, and null, one of the ways we can do that is we can import flatten. So let's do that. We'll use flatten from underscore, which just takes an array of arrays and turns it into one array. It just sort of like collapses them all down into one array. Underscore, cool. And so when we are going to have another thing called num occupied seats, and this is going to take in an array, which is our seats. And then what we'll do is we'll just flatten the array, and we'll filter it based on the value. If the value, I guess we can not the value. I don't know if you remember yesterday, if you were watching yesterday, but we did this, or maybe it was 2 days ago, and I explained about the double inversion to cast things to Boolean. So it's like not null is true and not true is false. So null is false in this case. So we can filter on this. Again, it's not strictly necessary because JavaScript does these types of conversions for us. If we try to evaluate if a string, then it will, or if a value, it will try to cast those for us. And in this case, it would cast null to a false. But I like putting these in the code just as an indication that, hey, this is being explicitly coerced into a Boolean. This is what I'm expecting. So we're filtering for the trues, and then we are going to check the length. And this will give us the number of occupied seats. So I guess what we can do is we can assert that the number of occupied seats for parse input, we can assert that 0 is, and that blows up. So let's flatten is not a function. Really? Oh yeah, I did this thing again. All right, require underscore. What's it angry about now? Input is not a function. Parse input, input. Input is not a function. Input. Where is it seeing input? It's expecting input to be a function. On line 105. Whoops. That's the typo. All right, beautiful. So assert that. Let's get another case here as well. So I'm just gonna double check that this works. This is the final state, I think, we're 35. So this is, we'll say final state equals, and whoop, cool. And if we, these are the occupied seats. Oops, let's paste them. So 30, so there are 37 of these in here. Okay, so I don't know if I did that wrong or if this isn't the final state. Maybe this is just the third state, but we want to, I think, or the fourth state, because technically the first state is the first state. So this is gonna be the fourth state. So I'm gonna assert that 37 is and fourth state, just to make sure that this count function is actually working. And it is. Okay, cool. So we don't need this anymore. I just wanted to use it to assert that the fourth state was correct. So we've got our input parsing, we've got the number of occupied seats counter. The next thing we want to do is we want to process one, in like Game of Life, we would call this like processing a generation or whatever. I don't know what we should call it here. Let's look for hints as to a good name. I've learned many times that naming things is extremely important and extremely difficult. This is not news to anyone, I'm probably sure, but okay, so this is going to be I don't know, number of occupied seats, one round. Okay, so this is going to be run round, I guess. This is, maybe that's a terrible name, but whatever. So we're going to take our what should we call this, our map in. Oops. So we're going to call this run round. So we've got our map, and what we're going to do is, like I mentioned before, like a frame buffer. What we have to do is we have to evaluate the entire map as it is, and then we want to apply those changes to a new map. So new map equals map. So this would work for a single array, but since we have two, we have a nested array, we've got like two levels of arrays. Probably the easiest way to do this would be to JSON decode JSON stringify and map. So let's see what we get if we just run that. Let's see. Let's see if we get the same thing out. Log run round. Whoops. Parse input. What was this? JSON decode. JSON. Was that parse? I forget. Yeah, it's JSON parse. Okay, so this gives us false, null, false, false, null, false. So this is giving us the same thing back from that we got originally, which is good. And if we did something like, no, it's the wrong one. Here we go. We had made the first one true and ran it. False equals true. Yeah, oh, right. I have to turn off that assert. Then we get a true back. Okay, perfect. So this is going to clone our map. So we've got map and we've got old map. So what did this even do? So JSON stringify map, this just turned it into a big JSON string, and then this just read that JSON string back. It's sort of like a fun, cheap way of doing like an absolute deep clone. As long as your data is JSON safe, as long as you don't have any like class instances or anything like that in your data, this is a pretty easy and foolproof way to get a deep clone of something. And so you know that none of the objects in there pass by reference. I use this a lot. Definitely helpful. Okay, so the first step of run round is run round. Give me the run round. the first step of this is going to be going over and determining if the rules apply. So the rules, and we have to evaluate the rules for each cell. So what does that look like? So if you look at these inputs, what we're going to do is we're going to be like, let's take a random thing like this guy right here. What we have to do is we have to look at the 8 spaces around L. Like we have to look at these guys and not this guy, obviously, but we have to look at these dudes right here. And we have to see if, we basically just have to see how many of them are occupied. That's the only thing, right? If a seat is empty and there are no occupied seats adjacent to it, the seat becomes occupied. So if we need to know if this seat is empty, and if so, the seat becomes occupied. If the seat is occupied and 4 or more adjacent seats are also occupied, it becomes empty. Otherwise, the seat's state does not change. So if the seat is empty and there are no occupied seats, it's occupied. And then if a seat is occupied and 4 or more seats are adjacent to it are also occupied, it becomes empty. So we need the number of adjacent seats that are occupied, and we need to know the state of the seat itself. So even if we did this here, we would still be looking at this group, and these would just be false or null or undefined. So they wouldn't count. Whoops, I've made too many. There we go. So these guys wouldn't count. We'd only count these occupied seats. And so we could actually just sub in null for these guys and it would be fine. Really, all we're looking for is the number of trues. So, all right, so what does that look like? What does, say we're here, what does this look like? So this is an offset of 1, 2, offset of 1, 2. So we need to look at 2, -1, +1, and then we need to do 2 minus 1, -1, 0, +1. Basically, we need to do from the previous row. I don't know, the camera's not picking me up. We need to do basically the previous row, -1, 0, +1, and then the regular row -1, and we can ignore 0, 0. And then +1, and then +1, -1, 0, +1. So we need to grab the values for all of those if they exist. Otherwise, false is fine. Cool. So let's make a thing that does that. Let's num neighbors, and we're gonna take in the map. And we're going to take in, let's say, yx, just because I don't want to get into x, y, yx bullshit. Okay, so this is going to give us the vertical offset and the horizontal offset. And so what we want to do is we want to say for the delta y in whoops. What do we want? Y -1, y, and then y +1. And then for dx in, we're gonna do the same thing for x. Okay, and we can use this to skip. Or I guess what we can do is we can continue if x is y is 0. So if they're both 0, otherwise what we want to do is we want to say map y, and if that exists, then we'll go x if that exists, or false. Cool. And what we'll do is we will track the num, and we'll say num plus equals 1 if. Okay, so, and then at the end of this, we're just going to return the num again. So num neighbors, so let's test this num neighbors for this, it should be 0 always, I guess. This and x. Okay, so this will be null. Okay, so let's test num neighbors. We'll log num neighbors for to parse input. Let's see what we get. We are also logging that, which is annoying. We don't need to do that anymore. So 0. Okay. So let's change the input and see if we get a new result. So this is 2, so let's change these two to trues and see what we get. Okay, we get it blowing up. Oh, assertion false equals true. Let's turn off this assert for now. So it's still giving us 0, which is interesting. So 2, so this would be 1. Let's do let's spit these out. Log. So it's always giving us false, but it is checking 1 2 3 4 5 6 7 8 9. Okay, but it's it's not continuing. Is 0 if x is y is all we care about. So no, if x dy and dx, yeah, that's why, dy dx, and then this would be dy. See, we went through all the pain of naming these variables, and then we forgot to use them. Okay, so true, false, null, null, false, false. So it gives us 1, and I don't think that doesn't sound correct because we changed this, so it should be true, true. Are we skipping? Oh, right, is y or x, I guess. So if, what do you want? dy is y and dx is x. So this true, true, false, null, null. So top left, top middle, top right, and then left, right, and then bottom left, bottom right, bottom middle, bottom right. Okay, so that gives us 2. So that's good. Okay, so I feel like this works, and we'll try. Whoops, I forget what this was supposed to be. So I think they're both empty seats. I guess we can find that out. Yeah, all of those, that entire row is seats except for that one. Okay, cool. So num neighbors works. So what we can do here is we can start applying the rules. The rules are, I've read them like 50 times, but I'm just going to copy them into the code. Here we go. Otherwise, the state does not change. Okay. For y in map, for x in, I guess this can be row, and for column in row. Whoops. So these are the rules that we're doing. Okay, so if a seat is empty and there are no occupied seats, so what we want to know is we want to know the num neighbors. And we're gonna pass in y/x map. So that's row, column, map. If a seat is empty and then the current state equals map row call. This is going to be row y, and this is the y index, and then this is going to be call x. So this is going to be And then this, well, this is going to be for value x. So this is going to be y, x, y, x. Okay, and then actually we already know this because we're already iterating over the value. So basically the value, this, if the seat is empty and there are no occupied seats. Okay, so if val equals false and there are no occupied seats adjacent to it, num neighbors is 0, the seat becomes occupied. So we're gonna wanna modify the new map. I guess the other thing we should do, we should continue if row or if val is null. So here what we're doing is we're basically skipping the non-seats. Okay, so this is our first condition. So the seat becomes occupied. If the seat is occupied and 4 more seats are also occupied, it becomes empty. Okay, if val is true, I guess this can be is false. So this would be occupy seat. And this would be if val is true and is greater than or equal to 4, it's 4 or more seats, right? Yeah, 4 more seats, then it becomes empty. Whoop. Leave seat. Else nothing. Else we leave it alone. Okay, cool. So we want to flip the seat in these cases. And so what we can do here is we can just say, in fact, in both of these cases, so the interesting thing here is if, this would be else if. So in both of these cases, what we're actually just doing is we're flipping the value of the seat. So we're saying that new map for y and x is not what it was. And in fact, that's also what we're doing here. So what we can do is we can do this. We can have these conditions here, or, and, oops, this would be regular or. Like that. So we could do it like this, and that would be shorter, but I don't like it because I don't feel like it reads particularly well. And I think the most important thing for me is that something reads well. The same is true here. So our new map currently is an exact copy of the old map, but I like the indication that we're actually reading from the old map and writing it to the new map. In fact, in this case, we don't even have to read from the old map. What we can say is we can say we want to occupy the seat. So this is more code, but I feel like it's better because it reads nicer, at least to me. Okay, so run round will give us the new map. Okay, because otherwise the state doesn't change. So this is what we have. We have run round, takes a map, gives us a new map. Okay, and we want to run these rounds until they stabilize. And so what does a stable round look like? A stable round is when the round that you just had and the round that you get out of run round are the same, because if it didn't change, that's the only input to the function. If it didn't change in one round, it's not going to change in the next round. So so let's make a new function that says run rounds, I guess. Ugh. And this is going to take in a map, and this is going to run them until they're stable. Okay, so we're going to have the old round and the new round. So run round is going to generate the next round. I guess what we can call this is, instead of run round, we're going to call this, let's call this next map, and we'll call this, I guess we can just call this run. It's kind of shitty though. Okay, so we have well, so we're gonna have new map equals next map map, and well, new map isn't map. What we'll do is we will do this. We'll say new map equals next map, and then map equals new map. Wait, this isn't correct. So we want to update. Oh, okay. Oh, okay. I see what we're gonna have to do. We're gonna have to sort of like, we're gonna have to update it so we change map to be new map. So new map. We want map to become new map, and we can. I think we can do this with destructuring actually. So we can have that equals. So that's the old new map, and then the new map is going to be next map map. And then when we're done, we will return new map. So this, I mean, we don't really need to do that. So this is going to run until we're stable. So let's just log a dot here and see if this runs forever. So let's run oops, parse input, and we'll log that response. Okay, so this is running a lot and it's logging a lot of stuff because we have some more logs in here somewhere. Log. Oh no, it's not. Oh yeah, it's logging that. Okay. So okay, this is gonna run a lot. It doesn't seem to be stopping. Please stop. Oh god, I think I've killed Sublime. That was not a clever thing to do. Oh, and I think I know why too. So right here we're comparing new map and old map. But what we really want to do is we want to compare whether they're equivalent, because they're not the same object. So I think I've killed Sublime. It seems to be stuck. I'm going to kill it and then reopen it. Sublime, where are you? Yeah, there it is. It's dead. RIP. Let's reopen Sublime. And we'll not make that mistake again. Okay. All right, where was it? Neighbors no longer run. Okay, so we're still here. So JSON dot stringify new map isn't JSON stringify map. Let's put a counter in here. You know, 500 max equals 500, and then we can say we'll max and then we'll say well, and max is above 0. Just being paranoid here. Minus equals 1. Okay, so we'll have a maximum of 500 loops, and then it'll hopefully it'll break and return the new map. But let's see how many we get. Okay, cool. So it did 8 iterations, it looks like. No, it did 500 iterations, and then it gave us an empty array. So maybe this isn't working. So that's possible. Okay. At least we didn't crash Sublime this time. So let's log map. Oh god, this is gonna be yeah, this is gonna be, let's log the first row of map, and we'll join it with commas. Actually, we'll join it with nothing, and then we'll do the same thing for new map, and we'll do that every iteration as well. Okay, so cannot read property 0 of undefined. So that's interesting. So it doesn't like. So it went into the first loop, and either next map is not giving us. Okay, so let's see what next map is. I guess we never tested next map. So log next map parse input. Let's see what we get here. True, null, true, true, null, true, true, null, true, true. Okay, so this is actually giving us what I would expect it to give us. And then if we log the next map, true, null, false, false, null, false. So this feels like it's doing the right thing, at least to me. So let's, whoops. Where do we go? No. Okay, so let's run that again. Okay, so let's grab these together. Oops, new. And let's double check. So this is after running one iteration. So the trues become, what are they, hashes? The nulls remain as dots, and then the falses are L, I think, and then these spaces get rid of, and then you know what, the commas we get rid of as well. Okay, so this is what it looked like theoretically, not there, the second one. Okay, interesting. So this is not correct. I guess maybe this is what we should be doing. We should be, oh, it's this one. Yeah, so that's this one, and then the next one should look like that. Okay, so that was correct. So this line matches this because we flipped it once. Yeah, so we flipped this once, and then we flipped it again, and then it turned into this. So I think that's, make sure I'm back. Okay, so I think next map is actually functioning correctly. So it must be this run that's not. So while JSON string find new map isn't, right, JSON string find map. So I guess what we'll do is we'll do the long version. We'll do temp equals next map, and then we'll say new map equals temp, but we'll also say map equals new map. Is it new map or next map? New map. So we'll grab a temp, we'll create that, and then we'll put new map to be equal to that, and then let's try, oh, we still want to do that. Oops. Okay, so finished, and this is the map that we get. So that worked. It was like, yeah, I guess the whole like bait and switch thing that we were doing wasn't working. So we do have to put it into a new variable. So it's kind of upsetting. I was really hoping that we'd be able to do that destructuring thing, but I mean, whatever. Okay, cool. So we've got this working, and we're going to log run. Oh, we don't need to log that. Oh, actually, you know, we don't know that we have that working because we weren't running that. We were running the other thing. So should we risk it? Should we risk crashing Sublime again? Or let's put the max stuff back in. Okay. All right, there we go. I don't feel safe after having crashed Sublime last time. Okay, so no, this ran all 500 iterations. So I feel like it just never stabilized. So let's take a look at what map and new map are. I guess we can also say until. but whatever. Okay, so let's log map dot join, and then we'll log new map. Is new map a thing yet? No, new map isn't a thing yet. Here, let's try it here. Okay, so this is freaking out. Cannot read property 0 of undefined on 146. Are we not? We are running parse input. We're running. Is it the fact that it's called run? No. So we got this map. JSON stringify isn't JSON stringify. Okay. Oh, because we're setting it to new. We're setting map to new map, but we haven't. Oh, I see. Okay, so all right, let's think about this. So we create a temporary variable to store our next map. Because we only have, we need to do this once basically. I think we need to assign map to new map. We need to do one, we need to do this, right? We need to do this once to generate one of each map first. Okay, so we're gonna do new map equals next map. So this is going to give us a new next map. Okay, so let's see if that works. It did, and it seemed to run once. But that's because log run true, null, true. So this gave us one run. So new map equals next map. And then what do we want to do? We want to have map and next map. So this is going to, okay, so this is, is this just going to give us the same thing? So it's a new map. Well, it's not the same. We want to do the same thing, but we never overwrote map with the old map. So map equals new map temp, and new map equals temp. So wait, I feel like this should have worked actually. Yeah, I'm confused about what's going on here. So this is upset because it can't read property 0 of undefined on line 147, which is here. It's saying that, map equals new map. So that's setting the map equal to a map that we haven't created yet. So temp, do I have these backwards? And then map. So this is the old map, and we're creating the new map. And then, yeah, maybe I've got this. Maybe I'm just not thinking about this right. Okay, so we've got temp, new map. So we're generating the next map. And somewhere a dog barks. Okay, so this is the map that's coming in. We generate the new map, which we're sticking here. And then, yeah. Okay, so let's just think about this. So we got new map equals the next map. And whoops. Yeah. Okay, if they're not the same, or I guess while they're not the same, what we want to do is we want to take we want to generate new map from the old map. So while they're not the same, we want to say map equals new map, and then we want to say new map equals next map map. Oops. Yeah, we're going to continue logging that. Okay. So, all right. So, okay, so we're going to make the new map, which is the next state. If they're not equal, or while they're not equal, we are going to make a new, so we're going to copy new map into old map, and then we're going to generate a new map from the old map, which is the new map. No wonder it's confusing. Okay, so this runs about 5 or 6 times and then dumps out a map. Okay, so let's take a look at, let's take that out. Okay, and we can remove this map max logging. Okay, so we're gonna run that and we get out this map. And what does this map look like? True, null, true, false, null, false. So we want it to look like our final thing, and we want it to be, we want num occupied seats of running that, and we want to log that. So that should be, what is it, like 37? Yeah, oh wow, okay, and we're getting 37. Is that what we wanted? Yeah, count 37 occupied seats. Okay, so assert 37 is num occupied seats. And now what we want to do is we want to actually run this on the actual input and get the number of occupied seats. And that's what we're going to do. Parse input, and we'll say require input, which is not a thing yet because we haven't gotten it. So get our puzzle input. All right, cool. And the map, of course, is changed size, but that doesn't matter because we haven't hard coded anything. So let's make our input file. All right, and module.exports equals. All right, and running that, we get 2321. So is that the right answer? Let's find out. That's the right answer. Okay, cool. So we'll continue to part 2. Part 2 says, as soon as people start to arrive, you realize your mistake. Uh-oh. People don't just care about the adjacent seats. They care about the first seat they can see in each of those 8 directions. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of those 8 directions. For example, the empty seat below would see 8 occupied seats. The leftmost empty seats, okay, the first seat in each of those 8 directions, for example, the empty seat below would see 8 occupied seats. 1, 2, 3, 4, 5, 6, oh my god, 7, 8, oh my god, the left C, wow, this is going to be interesting. The empty seat below would see no occupied seats because it's empty in each direction. Also, people seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty. Okay. So num neighbors is going to change. Okay, again, at this point, people stop shifting around. You count 26. Okay, cool. So this actually doesn't seem like a huge deal. He says convincingly. I think it's going to just change 2 parts of what we wrote so far. So let's dive into it. This is our it's just plain, oops, and then plain, okay, and then more plain, okay, whoops, plain, and then what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I guess we want that. How many is this? 44 to 53, so 55 to 64, and then 66 to 75, 77 to 86, is about right. 88 to 97. So these look about right. Yeah, 99 to 108, 110 to 119. Okay. Whew, there we go. Again, at this point, people stop shifting. Good. Yeah. Okay. So we're going to copy our work from part 1 because a lot of this is going to be identical. What has changed? So we're still parsing the input the same way. We almost generate the next map the same way, but not quite, but we'll come back to that. We're still going to run it the same way. We're still running it until they're not the same. Num neighbors, this has changed. So it used to be that we were just looking immediately around it. What we want to do instead is we want to sort of like cast rays out in every direction, and then num occupied seats stays the same. So num neighbors is now num visible, and that's going to be different. So we're still going to take in y, x, and the map. But how we calculate this is changing. So, all right. And now, so here we took a bit of a shortcut too, because if we went off the array, it was false. Here, I think what we're going to want to do is we're going to want to explicitly travel in one direction, each direction. We're going to want to travel until we reach either a seat or the end of the map. So we need to be aware of the map's width and height. Okay, so how can we do this? I guess we also need, this is our input from the first one. I don't think we have this input in the second one, unless it's up at the top here. Yeah, empty seat below, instead of considering just, yeah, okay. Given the same starting input as above, so let's just throw this in here. Oh, this is our starting input. It would do as follows. Okay, cool. All right, so num visible. How is this going to work? Given this input, we're going to start in the first seat, and we're going to look. We're going to look in every direction. We're going to look up. We're going to look down. We're going to look left. We're going to look right. We're going to look diagonally. And so, and what does that even mean? So if we're in this seat here, we're going to look up. We're going to not see an occupied seat. We're going to look up. We're going to not see an occupied seat. And then we're going to look up, and we're going to get off the map. And once we hit the edge of the map, we're going to say, okay, I can't see anyone in this direction. And we're going to do the same thing for an x offset, or an x offset of 0 and a y offset of -1, and we're going to just keep going up and up until we run off the map. And we'll do the same thing with an x offset of 0 and a y offset of +1. So every loop we're going to go and we're going to check y + 1 until we reach the end of the map. Whoops. And we're going to do the same thing with y being 0, and then x -1, and then x +1, and then to check the diagonals, we're going to do y -1, x -1, y -1, x -1. So we're going to keep on going out until we reach basically one of the array boundaries. And if we ever occupy a true, then we count that. Okay, so that's how we're going to search the map. So we are going to start. We're going to count our num at 0. So we're going to do something. So we're going to have dx for, I guess we're going to say for dx in -1, 0, +1. And we're going to do the same thing for dy. Let's do dy first. What we're going to do is we're going to start at map. And we're going to look at, so we're going to have to define a coordinate, and that coordinate is going to be x and y. Okay, so we're going to look for the cell is going to be, so x plus dy, and then, or y plus dy, x plus dx. And we're going to have to keep adding those. So search y equals y plus dy, and then search x is going to be x plus dx. So the first one, this is going to by default search the -1. So we're going to want to look at search y, and then it's going to be search x. So, and we're going to want to make sure that it's null and not undefined. So if it's undefined, it's gone off the map, and I think this just give us null, or will this give us undefined? I'm not sure. We're going to have to check that. Okay, so this is something that we can check before. We're going to have to check that, and we will do that in a second. So we're going to have to do this until this gives us a true. So if it gives us a true, then we can just add num and move on. If it gives us a false or a null, then we want to keep looking. And if it gives us an undefined, then we have exhausted this direction. We want to continue. So let's, okay, so while I guess we could do val equals, yeah, okay. So I guess that, yeah, the first thing we should do is we should determine whether or not we actually get an undefined if we go off the map. So let's grab a map here and just poke around with it. Map equals that. Okay, so let's look at map -1 4 and just log that. What does that give us? That gives us log undefined. Okay, good. So what if we do +9 and 4? That gives us a false. What about +99 and 4? That gives us undefined. What about 5 and 44? This should also give us undefined. Good, it does. And 5 and 5 gives us false. So we've got true, false, null, and undefined. So undefined means we're off the map. So, okay, so we want to case or switch on this. And we can say when undefined, we want to break. We want to break out of this loop and move on to the next one. When true, we want to num plus equals 1, and then break. And then else we do nothing, we just continue the loop. So maybe we could do else continue, but that is meaningless in this case. Okay. I guess what we'll want to do after we inspect the value is we're going to want to continue this loop. So, well, true. So it's always going to get to an undefined. So search y. So we're going to initiate search y here, search y and search x. So these are the current values, and they're going to, I guess they're going to equals y and x. And then we're going to say every time we're going to plus equal. So we're going to increment them. So that way we can continue to move in the direction that we are going in, and then we check it. Okay, so num visible, let's change our input like we did last time, wherever that ended up being. So we'll go 1, 2, 3, 1, 2, 3. So this is going to be an offset of 2, 2, and then we'll want this to be 1 visible, or let's do 2 visible. So let's see if that's 2 visible. So we'll say we want to log num visible for map, and we want 2, 2. So we want this to be 2 visible for 2, 2 on the map. And it is gonna run forever for some reason. Okay, so switch map, I guess let's log search y, search x, and then we'll map search y, search x. Okay, so search y and search x are getting extremely negative, and we are getting undefined, but it's only breaking out of the while loop. But we actually want to break 2 because we've hit the edge, and I think here as well we want to break 2. Break 2. How do you break twice? JavaScript break 2 loops. How to break nested loops in JavaScript. Yeah, you can. I tried this. No, that doesn't work. Break dance. Oh, interesting. Okay, you can break to a label. Interesting. I did not know you could do that. Okay, so we want to break. Where do we want to break? We want to break. I think we actually only want to break. I thought we only wanted to break 1 actually. So we want to break out of this while true loop. Or maybe we want to continue. Maybe that's what we want to do. Is we want to. No, we don't want to continue. Oops. Break. Yeah, let's see what they do. Dance 4, 4. Okay, so inner. Oops. And then what do? We break. Break inner. Yeah, it doesn't like that. Unexpected new line. Is that because it's not a supported statement in Java in CoffeeScript? That would be the first time I've ever seen that. Unexpected new line, break inner. Whoops. Okay, so results 2 push break inner. Let's see if this is not working. No. Break. Yeah, it's a keyword. break inner. Huh. I think one break should be enough though. So that should break this while loop, and then it should continue in there for dx in. I mean, we can just done equals false. So until done, and done equals true. Done equals true. We can do it this way as well. See if that works. Okay. All right, and log num visible, and then oh right, we want to return num at the end here. Num. Okay. And then that gives us 1. Relogging. Search. Okay, so it searches -1, -1, and it gets undefined. Oh, okay. So search y is y, search x is x, plus equals dy dx, and then we're logging that. So this is weird. This is not logging the correct thing. So for dy in for dx. So why is it giving us -1, -1? So we want it to be plus equals. So this should be y and x from here. So if we pass in 2, surely it should have oh, and we also shouldn't be checking 0, 0. So we can continue if dy is 0 and dx is 0. Okay, so that should show one fewer things. Okay, so the first thing it should be doing is it should be going up left, and the coordinates that it should be doing are 2, 2, unless we're doing parse input. Yeah, we're not running anything else. So the first coordinates that it should be trying are 2, 2, -1 each. So why is that? So let's log what search y and search x are, and let's log what dy and dx are. Dy dx. Okay, so 2, 2, -1, -1. Okay, so then now it's logging 1, 1 is false. Okay. Why did that fix it? Oh, maybe it didn't. Maybe I was just not looking at it. Then it got to undefined. Okay, and then it started looking. It would have been looking -1, +1, so it would have been looking down that way. So it looked at 1, 3, 0, 4, got a null, then 1, 5, undefined. Okay. And it found a true at 3, 3. It should have also found a true. It should be also checking up and down and left and right, and it doesn't seem to be doing that. So that's interesting. So for dy, and it should be checking. So it's never checking anything with a 2 in it, which is a bad sign, because that means that it's not looking left and right or up and down. It's always looking in the diagonals. So let's log dy dx, and let's do that right here, and see. Oops. We'll see if we're actually So this should continue if dy is 0 and dx is 0. Okay, so let's just see what it logs. -1, -1, +1. So it's skipping 0. Oh my god. Whoops. And yeah, there we go. So now it's giving us 2. Whoops. 0 + 1 instead of 0, +1. All right, much better. Now we can get rid of that and 2. So that's what we wanted. Wanted to assert that 2 was that because we made 2 of them. And let's just, what is that supposed to be? That's supposed to be an L. Yeah, L. Let's put it here, and we should still get 2. And we do. And let's put it all the way. So this should give us a 1. Yeah, and then let's put it all the way down to the end here. And that gives us a 2. Okay, beautiful. So cool. Okay, so we've replaced num neighbors with num visible. And now what we need to do is in this next map, what we want to do is num neighbors is going to be num visible. Oops. Let's get all of them. Num neighbors, num visible is going to be num visible at yx map. And so if they're not, then it's going to do it. And if they're greater than or equal to 5, because people have a higher tolerance now, is that what it is? Again, at this point, people stop shifting around. What does it say? It takes 5 or more visible occupied seats. Okay, rather than 4. The other rules still applied. Okay. The new rules cause seating area to shift as follows. And then you count 26 occupied seats. So this is what we're going to do, is we're going to assert 26 is parse input. So is that true? It is not. Something is okay. So we're no longer enrolling that parse input. Oh, have I put input back, or did I not? Did I leave it? Put it with that. There you go. So it's still false. So I wonder how many seats we're actually getting. Let's log it. We're getting 0 back. Num occupied seats. So do we do something here? Num visible. Okay. And I guess what we could do is we could also log. Oh, you know what? We're not running it. Oops. Run. So 15. So it's still not giving us the right answer, but at least it's giving us a non-zero answer. maybe that's harder. I don't know. Eventually, though, what we'd like this to give us the answer. Was it 26? Okay. 26. Once it reaches equilibrium. So let's take a look at what goes on between this state and that state. You know, it would have been really handy this whole time to have like an opposite of parse input where we generate a map. So let's say let's say log map. Let's just create a log map thing that takes in a map and does the opposite of parse input. So this is the switch. So we're going to say for row in map, and then for val in row. And we're going to say log, or I guess we're not going to want to log that. What we're going to want to do is we're just going to, for road map, we're going to log, and we're going to log row map, and we want to make these substitutions. So we want to take val in, and then we'll say switch val when true, when false, and when null. I'm gonna put them back like that. Okay, so let's see if we can log map now. Log map. So, oh, and we should, so it is actually going to be logging theoretic. Oh, we should log that join, whatever. Okay. Log row map. Let's say row map join. Let's join it with nothing. Log row map like that. Does that work? This for row and map, and then I guess what we want to do is we want to, what do we want to return? We want to return null. Yes. Okay, why cannot read property join of undefined? Log row map join. Let's try that. There we go. So this is what we're getting back at the end, is we're getting back this guy. And what are we supposed to have at the end here? Oh, I don't know if this is actually at the end. What we should do is we should check the next state. So rather than run, what we'll want to do is we'll want to check out next map, log map, next map, and see what this gives us. So this should look like the first one here, and it does. Okay, and then let's do that again. And we'll see if this matches up with, whoops, where is it? Let's see if this matches up with this guy. Whoops. Looks good to me. I don't see anything particularly off. Okay. So I guess I'm assuming that this will continue to just be correct. I mean, we'll try one more, but I feel like maybe any more than that would just be kind of ridiculous. Okay, and this, oh, this is, oh, wow, look at that. Okay, so in this case, we actually found a problem. This is different than it should be. So I'm glad, oh, hold on, maybe I didn't. Yeah, this is the same as this one, isn't it? No, it's not the same as this one. This is different. So it looks like this step diverged from what it's expecting. So wow, okay, I'm glad we checked this. This means that there's something we're not doing correctly in this next map function, or something we're not doing in this num_visible function. So let's double check that these are equivalent, just to be extra safe. Dot dot l dot dot, yeah, ll l dot ll, yeah. Yep. Okay, and then this is where it goes completely wrong. So let's take an example of where it went wrong. So this flipped, and it flipped because it saw 1, 2, 3, yeah, 4, and 5. It could see 5 neighbors, and so it flipped. Oh, I guess no. So I'm comparing this against the wrong thing. So it was here, and it would have seen one, two. It would have seen two neighbors. Oh, maybe it would have seen, no, because it's the fourth one. So it would have looked here. Yeah, it would have seen two neighbors. So it shouldn't have flipped, but in this case, it says it did flip. So that's really interesting. So that, what does that say? That says that either our understanding of when it should flip is wrong, or Advent of Code is wrong. And I'm gonna assume, because I mean this is all they do and they're very smart people, I'm gonna assume our understanding is incorrect. So let's take a look. Let's just read it on the webpage because it's easier. Okay, so would only see one empty seat but cannot see any of the occupied ones. The empty seat below would see no occupied seats. Also, people seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty. So if they see any, they will flip. Is that what it is? Okay, so if they see any, it's any that they will flip. So this guy should have flipped because he sees one, but then this one, should have flipped as well because it could also see one. Is this right? Okay, given the same starting layout as above, these rules cause the steering shift around as follows. People seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty. The other rules still apply. Empty seats that see no occupied seats become occupied. Okay, so, right, so they see no, they become occupied. So in this case, this guy presumably would see no occupied seats. Maybe our understanding of what people can see is incorrect. So instead of considering just the 8 immediately adjacent seats, consider the first seat in each of those 8 directions. Oh, the first seat, not the first occupied seat. Okay, so our definition of visible seats needs to change. So so right now, if we're seeing an empty seat, like we're looking through the seat at the seat behind it, and we don't want to do that. So when false, done is true. And so we're not going to increment the number, but also we see that there's an empty seat, and so that's all we care about. So I think that might be enough to do it. So what we want to check if num occupied seats, this should be 26 now, and it's now 0. So let's look at log map that. So this is now the first iteration. This should give us the same thing that this did, and it does. So let's check another log map, or another next map on that. And this is what we get here. Where are my maps? Where are my maps at? All right. Oops. Come on. So that's the same. And then the next one is where it did diverge previously. Right. Next map. This is where it had diverged previously, and now it looks like it matches. So L, yeah, yep, 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 yep. Okay, it looks right. Let's give it one more because we went off the rails last time around this way. So, okay, this is the next one. And this looks right to me as well. So I guess the question is, oh, because we weren't running, maybe. Next, run. So let's log that. 26. Okay, so we weren't running, we weren't hitting run, we were just doing next. Okay, assert 26 is, whoops. All right, and now what we can do is we can log num occupied seats, run, parse int, require input, and get the actual answer that they're looking for, which is 2102. Is that what we got last time? No, 2321. So 2102. So let's see if that's correct. If that's correct, then we can move on to refactoring and committing. That is the right answer. Nice. Okay, so yeah, let's take just a brief look over the code, and we can remove these. We can remove all of this stuff that we put in here for debugging purposes. Yeah, you too. Okay. Cool. So flatten. Are we still using flatten? Yeah, we are. Okay. So parse input. This is basically just taking this text block, splits it by new line, maps over the rows, splits it into an array, and then maps those values, converts these symbols into these values. We could refactor this out a bit and make like a map. So we could do, or a dictionary. So we could have like, that is true, and then we could just sub the value in. And then for log map on the way back out, we'd have to like sort of like reverse that dictionary. I don't feel like that's super valuable. I think having it in line like this is fine. Same thing here, log map. What we could do is we could do map row, and then we could capture this, and then let's try this rather than just trying to log it in line, and then row map join, and then we could say for row in ret. I guess we could say for row in, no, whatever, ret. We could like log row. We could do, so we could map the values and then we could print them out. And then return null. So we could try that. And let's see if this works. Log map. Let's turn that off. And then we'll just say log map, parse input. Yeah, okay. Kind of like that better. It's now two steps. Like we're doing the dictionary substitution, and then we're logging them. We could probably cut that down. I find that this is just a lot more readable. We're mapping. It's called map. I don't like that, but that's fine. Okay, so next map. So this is where we're making a deep copy. It might be a good idea actually to leave some notes in here. Make a deep copy. No references. So that way we're not passing any of these things by references. That way future people who come along and look at this will be like, oh, why are they doing this? It's the same thing. You can just copy it over. And it's like, no, it's not the same thing. It's different objects in memory. Then for row y and for val x, we continue if val is null. So let's do this. What we want to do is we want to, yeah, what did we care about here? Making the next map. So this would be skip floor spaces. Okay. And then this would be the num visible. So, I mean, this is sort of self-documented. And this would be if val is false and the num visible is 0, occupy seat. And this would be vacate seat. Okay, and then this is return the new map. And then here, this is just run until stable, then return. Just give a little idea of what that does. And then here, same thing. What we'll do is we'll say how many visible seats are occupied, and let's leave a note in here that empty seats block your view of other seats. Empty seats also block your view of other seats. So leave a note for future generations to come along and say, hey, they left this note here about empty seats, so this is why we should pay attention to this. So maybe we can leave a note in each case here. So map false, we'll just say seat visible unoccupied. Oops. We see the wall. And then this is seat visible occupied. Okay. Num occupied seats. Yeah, this just flattens the array. Okay, cool. So we've left some notes for future us in here. And there we go. So log map we introduced here and we didn't use in the other file, I don't think. The other file is going to be largely the same. Parse input. Next map, I guess we can copy over our note about making a deep copy. And what was our other note in here? Continue skip floor spaces. That's super valuable. And then num neighbors and occupy seat and vacate seat. Let's do that as well. Occupy seat, vacate seat. Okay, and then run. Our run note still applies. Okay. Return map. And then num neighbors. So right here we had this num visible note, and now we have this num neighbors note. How many occupied seats, or how many adjacent seats are occupied? Cool. I don't think the rest of it needs any explanation. So cool. This still runs 2102. This still runs 2321. Okay, I'm pretty sure those are what we had. So what are we going to do now? We're going to commit our work. Cool. That was fun. Git X. And that is day 11 in the can. And push main to origin. And cool. And then the README. Update the link in the README. I always forget to do this and have to do it after. What is this? Seating system. All right. And this was day 11. And watch the video ID is the video is copied over there. Whoops. There we go. And this would be an offset of 10. That's what I do every time. And then this will be update add day 11 to readme. Cool. Yeah, well, that took a bit longer than I was hoping, but I mean, like, it's not so bad. Yeah, it was fun. We made a couple of missteps just in our understanding of the rules, like is typical for Advent of Code. Usually when you get something wrong, it's because you weren't really paying attention to the rules that well. What else? We also had, I personally had a bit of confusion in this run loop about when I was making a new map and then when I was swapping the variables around. I was really hoping to do this, like, you know, AB equals BA. This is something you can do in CoffeeScript to swap variables, and it sort of like takes this temp for it. And I think honestly that probably would have worked. In fact, we can test if it works if I had already done this. So let's take a look. So map equals new map, right? So that is something that we're doing here. And then what we're doing here is we're saying and new map equals next map. So this is what I was trying to do. And let's see if this still runs. It does not. So maybe that's not something that I can do. So I'm curious about that. I'm gonna have to take a look at that, and I'll take a look at that offline and see why that kind of thing doesn't work. But yeah, shouldn't prevent us from from committing today's work. Okay, anyway, that was fun. And I'm gonna leave it there. Thanks for everyone who came along on this fun journey. Tomorrow we're going to be doing day 12. Yeah, that'll be fun. Oh, we've got, better than yesterday, says Blake. Yeah, true. Yes. It was better than yesterday. And I don't feel like I was as stuck as I was yesterday, which is good. With any luck, tomorrow will be a much smoother experience still. But we don't know. But yeah, anyway, I'm gonna leave it there. Thanks everyone for sticking around as long as you have, and I will see you tomorrow for day 12. All right.